All right, so we're looking at 3.3 today, dividing polynomials, the remainder theorem, THM theorem for short, and the factor theorem. All right, so let's look at long division first. All right, so if I had 5,867 divided by 11, if I wanted to set up my long division process, the 11 will go on the outside, the 5867 will go on the inside. 11 doesn't go into 5, but it goes into 58 5 times. 5 times 11. It's going to be 55. We're going to use this process. We're not going to be dividing out long division as far as numbers are concerned, but we will be using this process to divide our polynomials using the long division. So that's why I'm going through the process. 5 times 11 is 55. Subtract them. 58 minus 55, 3. Bring down your 6. 11 goes into 36 3 times. That's 3 times 11, which is 33. Subtract, that's 3. Bring down your 7. 11 goes into 37 3 times. 3 times 11 is 33. Subtract. And then we're done with the problem because there are no more numbers under the divisional bar or in the radicand. So now we can set up our answer. It's going to be 533. And then put that 4 over 11. Whatever we were dividing by, that's going to be that bottom number. And that is the long division process. So we're going to implement that same long division process into our polynomials, dividing our polynomials. All right, questions on that before we try it? All right, so we're going to divide x squared plus 10x plus 21 by x plus 3. So just like before, take what we're dividing by, put it on the outside. And the other piece, what we're dividing into, will be under your divisional bar. So we're going to compare first terms in each, x to x squared. Or in other words, x squared divided by x. And that will be x. So what you're asking yourself is what times x will give me x squared? And of course, that'll be x. So you can either look at it that way or go ahead and divide that out. We're only looking at the first term. That's what's going to dictate what goes on the top as a part of our answer, our quotient. What times x will give me x squared? All right, and that, as I said, is x. You normally line it up, over the same degree of x. So x will go over the 10x. All right, so now you take that x and multiply it to everything that's out here, not just the x with the 3 as well. Just like we did when we had the 5, we multiplied it times the 11. So x times x is x squared. X times 3 is 3x. Next part of the process is to subtract. So now we have to subtract each term. So x squared minus x squared will cancel. 10x minus 3x is 7x. Bring down your 21. Same process. That's what we did here, bringing down our digits. Now we're going to compare x and 7x. Say what times 7x, what times x will give me 7x? Or once again, you can do this. And we see that it's just 7. So plus 7 will go up here. 7 times x is 7x. 7 times 3 is 21. Subtract. 7x minus 7x cancels. 21 minus 21 cancels as well. Give me a remainder of 0. So my answer is just going to be x plus 7. Did not have a remainder. All right, questions before we do another one? All right. All right, so we're going to divide 4 minus 5x minus x squared plus 6x cubed by 3x minus 2. So you want to rewrite your terms in descending order when you go to set up your divisional process. So 6x cubed minus x squared minus 5x plus 4. All right. So compare first terms. What times 3x will give me 6x cubed? It's going to be 2x squared. So I'm going to take that 2x squared and multiply it to each term on the outside. So 2x squared times 3x is 6x cubed. 2x squared times negative 2 is negative 4x squared. So don't forget that minus sign has to go to both terms. A lot of people make that mistake here. They forget to give it to both terms, so make sure you're careful. So the 6x cubed minus 6x cubed will cancel. All right. And then here, negative to negative. So be careful with that. That turns positive. So that'll be a positive 4x squared and a negative 1x squared, which will be a remainder of 3x squared. Bring down your negative 5x. 3x and 3x squared. Asking yourself what times 3x will give me 3x squared. So you're looking at 3x squared divided by 3x, which is just x. So plus x goes here. X times 3x. 3x squared. X times negative 2 is negative 2x. Distribute. 3x squared cancels. Once again, negative to a negative turns positive. So negative 5x plus 2x is a negative 3x. Bring down to positive 4. All right, so once again, 3x compared to negative 3x. What times 3x will give me a negative 3x? That's just negative 1. So minus 1 go up here. That negative 1 times each one of those terms. That's negative 3x plus 2. Distribute the negative. Negative 3x plus 3x will cancel. Here my sign is minus. So 4 minus 2 is 2. And that's our remainder. We got to the end of our number over here. So that's going to be our remainder. So the answer is 2x squared. Might not have enough room. So 2x squared plus x minus 1 plus 2 over 3x minus 2. That's what we're dividing by. Questions? Any questions? All right, here we have x to the 5th plus x cubed minus 2 over x minus 1. So before we go any further, we have to recognize that we have missing terms. It skips from x to the 5th to x to the 3rd power, and then from x to the 3rd power all the way down to not having x at all. So you want your values for the exponent of your variables to go down in descending order, descending integers. So in other words, when I go to set this up, x minus 1 go on the outside. All right, on the inside, it's going to be x to the 5th. And what I'll say here is because of that, we need placeholders. All right, so x to the 5th plus 0, x to the 4th. Matter of fact, I'll do this. All right, plus x cubed plus 0x squared 0x. And I see your question. Give me 1 second. Minus 2. All right. Okay, I just saw this question. It says, would you type it in just like that in MATLAB? Are you talking car? Are you talking about the answer as far as the last answer we had? This one right here. Yes. So just make sure that this is the only one that has the denominator. 2 is the only one that's sitting over 3x minus 2. But yep, it will look just like that. 2x squared plus x minus 1 plus, and then 2 over the 3x minus 2. So yep. And then I had someone else send me another message. I do not need scratch work from a practice test or review test, just from the actual main test that we have out there. So scratch work is just for the actual test. All right. So going back to our example, we have these missing terms that we have to give an account for. We just have to have placeholders for them so that when we go through our process of long division, we'll be able to divide accordingly without any type of having to worry about skipping things. All right. So you say what times x will give me x to the 5th, and that will be x to the 4th. X to the 4th times x is going to be x to the 5th. Then times -1 is x to the 4th, negative x to the 4th. So we'll subtract that, distribute the negative. These cancel. Let's do my purple. All right, so the negative to negative turns positive. So 0x to the 4th plus x to the 4th, of course, is just x to the 4th. Bring back down plus x cubed. So you say what times x will give me x to the 4th? That's going to be x cubed. X cubed times each term. X to the 4th minus x cubed. Distribute. They cancel. So x cubed plus x cubed will be 2x cubed. Bring down 0x squared. Sorry about that. And then, so now we're comparing x, and it's 2x cubed. So you say what times x will give you 2x cubed? And that would be a plus 2x squared. So 2x squared times x will be 2x cubed. 2x squared times -1, excuse me. That's negative 2x squared. Go ahead and distribute that negative once again. All right. They cancel here once again. Negative to a negative turns positive right here. So 0 plus 2, 2x squared. Drop down to 0x. All right, so what times x will give me 2x squared? It'll be 2x. Yeah, I didn't know this problem had this many terms. I just chose one out of the back of the book. But then 2x times x, that's 2x squared minus 2x. Keep following the procedure. They cancel. That's a plus 2x now. And then bring down that negative 2. And what times x will give me 2x, and that'll just be 2. So 2x times negative 1, which is 2. Your distribution of the negative to subtract. And it ended up canceling out in both cases, leaving you a remainder of 0. All right. So that means since there is no remainder, this is our answer. X to the fourth, x cubed, 2x squared plus 2x plus 2. All right, questions on the process. Do I need to see anything else out of that one? All right, so that's the long division process. If you have any questions about it, then always feel free to ask. There's another type of division that we can use called synthetic division. All right. So synthetic division, you can only use synthetic division when the divisor is in the form of x minus c. So in other words, the highest exponent on your x or your variable is 1, and the number that's sitting in front of x, your coefficient, is 1. So when we look at that first example, x squared plus 5x plus 3 divided by x plus 2, I can use synthetic division for this problem. And the next one, we look at the bottom, you have x squared plus 2 because you have a square on your x, that 2 as an exponent for your x. You cannot use synthetic division. Then in that third one, you have 2x plus 2 down bottom. I cannot use synthetic division because I have 2 sitting in front of my x. So if anything is different than having 1 in front of your x and 1 is your exponent of x, you cannot use synthetic division. All right. All right, if we have x minus 3 and we want to divide that into x cubed plus 4x squared minus 5x plus 5, the first thing we would do is set it up this way. Let's see. So we're going to use the opposite sign that's attached to that 3. So if I have x minus 3, then the first thing I'll do is use plus 3 right here. Then we'll use this like this and write down all of the coefficients. 1, 4, -5, and 5. So that is your setup. All right. So we drop down this 1. And we're going to multiply three times 1. Put it right here, which is, that'll be 3. And we're going to add these numbers together. And that'll be 7. And we're going to keep that same pattern. This will be 3. We're going to multiply times that 7. Take it up here. That'll be 21. Add those together. 16. 3 times 16 is 48. You know, still keeping with that same process. Multiplying. Add these together. That'll be 53. This right here will always be your remainder. All right, before we finish it off, any questions with the process? So we're going to start with an exponent, one exponent less. than the original polynomial. So our original polynomial was x cubed. So when I go to write my answer, I'm going to start with x squared. So that's 1x squared plus 7x plus 16. So I just use all of these as my coefficient. Then plus 53 over whatever I was dividing by, which is x minus 3. Or the 53 is your remainder. Questions before we do another one? All right, here we have 5x cubed plus 6x plus 8, and we're going to divide that by x plus 8, x plus 2, excuse me. Nope, should not be any graphs this chapter. If I'm not mistaken. Nope, this is just solving. So no graphs, no graphs. No problem. All right, so got to be careful here. Got missing term. All right. So when I go to set up my not long division, my synthetic division, -2, because got to use the opposite sign. Got to use opposite sign. And then when we go to use our coefficients, we have 5, and what's missing is x squared. So we'll use 0. Then that's plus 6, not plus 6, just 6. And then 8. All right, so bring down to 5. And -2 times 5 is -10. Add them together. It's just -10. -2 times -10 is 20. Add them together, that's 26. -2 times 26 is -52. Add them together, that's -48. Oh, 44. All right, you can write our answer 5x. We started off x cubed, so it should be 5x squared minus 10x plus 26 minus 44 over x plus 2. Questions, questions, questions. All right, so the remainder theorem, if the polynomial f of x is divided by x minus c, then the remainder is f of c. So in other words, going back to the opposite sign thing, if I take the positive c and plug it into my function, that's going to be the remainder. And also remember, the remainder is this last number in our synthetic division. So let's try that out. All right, so given f of x is equal to x cubed minus 4x squared plus 5x plus 3, use the remainder theorem to find f of 2. So if they give it to us this way, remember when we do synthetic division, we use the opposite number of what we're dividing by, and also when we're using this remainder theorem, they use the opposite value to plug in for c. So this 2 is what we'll use in our synthetic division process. So just keep in mind that the only time you use opposite signs is if they not plug it in, give you the information this way. Your divisor is set up like this. So if it's x minus 2, that means I need to be using 2. If it's x plus 2, then I need to be using negative 2. Outside of that, they're going to give you the value that they want you to use. So if they give it to you with the variable in this expression form, you would be using the opposite sign. But they just give you the number, you use the number that they give you. My coefficients, 1, negative 4, 5, and 3. So synthetic division, bring down 1. 2 times 1 is 2. Add those together, that'll be negative 2. 2 times negative 2 is negative 4. Add those together, that'll be positive 1. 2 times 1 is 2. Add them together, you get 5. And this is our remainder. So now if the remainder theorem is correct, when I plug 2 into my function, I should get out 5. All right, let me check, make sure I got it right. X cubed minus 4x squared plus 5x plus 2. So plugging 2 into the function should give me 5. 2 cubed is 8. 2 squared is 4. 5 times 2 is 10 plus 3. 8 minus 16 plus 10 plus 3. 8 minus 16 is 8. Negative 8, excuse me. Plus 10, which is 2. 2 plus 3 is 5. So either way, you're going to get that remainder of 5. Questions on that? Just remainder theorem is just saying that when you plug that value in that you use for your synthetic division, plug into your function, you will get out the remainder. That'll let you know what your remainder is. And we're going to use that, I believe, in the next theorem to be able to tell what we have as far as solutions are concerned. So we have solutions that we're going to be looking for. Another word for solution is a 0. Also, another word for solution is root. So all of those terms are used interchangeably. Zero, solutions, roots are the same thing. But all right, so the factor theorem, if f of x, let f of x be a polynomial. If f of c is equal to 0, then x minus c is a factor of f of x. If x minus c is a factor of f of x, then f of c is equal to 0. So just to make sure we're okay with how this connects to what we've done in the past, let's say if I have x squared So how this connects is that, let's say if we want to solve x squared plus 7x plus 10 equal to 0, and we factor out the trinomial. So x plus 5 and x plus 2 are factors. And so that's what we're talking about here in the factor theorem. They're factors of x squared plus 7x plus 10. Now if I were to plug those, not plug them in, but solve those for 0, I would get x equal to -5 and x equal to -2. And so notice that that element or that relationship of the negative or the opposite sign comes into play. And that's how those things are related. Those are actually our zeros, our roots, or our solutions. Now, if I were to plug in either one of those into that function, x squared plus 7x plus 10, then I should get 0. So I'll just do one of them to show that. And that's where all this comes from. So let's say if we look at the x equal to -5. So -5 squared plus 7 times -5 plus 10. So it's -20, not -25, it's 25 plus -35 plus 10. 25 and -35 is -10 plus 10, that's 0. So that's what we're talking about. And that's the connection between your factors, plugging them into the function, getting 0, solutions, and all the good stuff like that. So before we use this in an equation, questions? use it in a problem, I should say, in the exercise. Let's just say 3 is to 0. All right, so solve the equation 2x cubed minus 3x squared minus 11x plus 6 equal to 0, given that 3 is a 0 of this function. So just another way of saying that 3 is a solution. Also, this means that when I plug in 3, I get 0 out. So if I were to plug 3 into that function, the result is supposed to be 0. That also means x minus 3 is a factor. You know, you use the opposite sign when you put it back with the x. All right, so what we can do is use synthetic division to break down the function. We use synthetic division to break down the function, recognizing that 3 is a 0, so I will use 3 and use the coefficients 2, -3, -11, 6. All right. Also, since we know that 3 is a 0, and according to the remainder theorem, 0 is supposed to be right here, according to the remainder theorem. All right. All right, so let's go ahead and do that. Bring down your 2. 3 times 2 is 6. Add these together. That'll be 3. 3 times 3 is 9. Add them together, get -2. 3 times -2 is -6. So if anything appeared right here other than -6, then somewhere we went wrong, because we had to get this 0 because they told us that 3 was a 0 of this function. So when they tell you something like that, you can't get anything different. So somewhere we would have went wrong. We could have wrote down a number wrong, wrote down a sign wrong. Something could have occurred. But just remember that when you go through this process, that's what's supposed to happen. All right. So now we can solve solve the remaining equation. So that'd be 2x squared minus 3x minus 11. Oh, I wrote down wrong. 2x squared, sorry. Plus 3x minus 2 equal to 0. Now we have to use these right here. All right. You can either use your quadratic formula or factor. So 2x and x plus 2 minus 1. So remember that comes back from last chapter. Set each piece equal to 0. And x is equal to positive 1/2. X is equal to negative 2. And don't forget x plus 3, the one that they gave you, is also a solution. So don't forget that one when you go to put in your answers. If they ask for you to solve or they ask for all of the solutions, that is one of them as well, even though they gave it to you. All right, questions. All right, so let's do one more like that, and I will be done with this section. All right, so 15x cubed plus 14x squared minus 3x minus 2. I want to solve that given that negative 1 is a 0. So set it up like we did last time, using the negative 1. And if it's a 0, that means 0 should be the remainder. And that also means that this should end up being a positive 2 right here. It's the only way I can get a 0. So if I have positive 2, all right, so let's bring down 15. Negative 1 times 15 is negative 15. 14 plus negative 15, negative 1. Negative 1 times negative 1 is positive 1. Add those together, we get negative 2. Negative 1 times negative 2 is positive 2. And so that gives us our positive 2 we were looking for. Questions before we go any further? All right, so now we want to solve what we have. So we're looking at, we want to get in the middle, negative 1, 5x, 3x. Then -2, +1. So it'll give me a 2, -6, and okay, that should be it. Set each piece equal to 0. X is going to be +2/5, -1/3, and then also -1. Those will be our 3 solutions. All right. Questions? Questions? Any questions? All right. So that's it for 3-3. So try this stuff out. We only have, what, 5 minutes left in class, so we don't have to do anything new. Next class, we'll go to 3-4. Continue to go from there. All right, any questions before we close? All right. So you guys have a good one. Be safe. And I will see you on next class.